is always 1/8 plus 3.
Oh.
Times.
Just like
I did
that.
that. On my
Yeah.
It messes you up. Okay, so next we go. Notes.
I feel like you've been taking lots of notes and not doing lots of homework.
Well, we're 3 sections in.
I got 1.
We're 3 sections into this chapter. So this is section 4. And there are 6 sections in this chapter. So, y'all should have 3 homework assignments.
Yeah, there's one new one, something.
And the other 2 were already due.
Yes.
Oh,
Last week was just a weird week because we only had 4 days. So,
I wish my list.
go over here.
I'm gonna have you see.
Your aim would be A instead of 3. Because your 3 is essential. It'd be 3 equals 1 over A plus 3/8 n, and then you have to solve for n. Don't worry about it. Yeah.
What if it just makes you feel like you're equations?
okay, applications of logarithmic functions. So we did applications of exponential functions, and these are going to look almost the same because remember, logarithms and exponentials are inverses of each other. So it's just going to depend on which piece of information that you're missing. So these are all going to look very familiar, or sort of. Okay, so one type of problem that is exponential and logarithmic are amplification problems. So, and they're found in decibels, which the abbreviation for decibel is lowercase d, capital B, by the way. So, like this. There is a formula for decibel gain. And it looks like this. Where EO is your output and EI is your input. So I'm going to write that down here so you don't forget. I'm assuming that the E stands for energy output and energy input. Just so you know, I think one of the things that trips people up with these problems, they're actually really easy, you just plug the numbers in. But one of the things that trips people up about these problems is the word gain. Like people just think, hey, gain, that means we're going to add or whatever. But in this sense, the gain doesn't, when they say gain, they don't mean to add something to. It's actually what you call it. There's a knob on an amplifier that's called the gain. And what it is the energy coming out of an instrument, let's say a guitar. The energy coming out of the instrument goes into the amplifier, and there's a knob called the gain. Yes? Kobe needs to go to the office. Thanks. Anyway, the energy goes into the amplifier, you turn the gain knob, and how much you turn that knob is going to depend on how much sound comes out of the amplifier. That's why it's called the gain. You gain that much energy. So when they say gain, they don't just mean add. Okay, so you just plug numbers into the formula, so this should be pretty easy. So I'm looking for my gain if I have an input of 0.5, so that goes on bottom, and an output of 40. Plug it in. You can just plug it into your calculator. I don't think it's going to ask you for an exact answer. If it did, that would be 20 log 80. But I think you'll just plug it into your calculator, and just be careful of how many decimal places it asks for.
Oh, is that a common law then?
Yes, I'm glad you asked that. Yes, this is common log.
Where is common law?
There's not a common log button on the Inspire, so you just hit log and put 10 in.
Okay.
Or you can type the word log using the keypad and then put a parentheses, and that'll assume common log. It's not so fast for y'all because it's not a QWERTY keyboard, but when if you were to have a Inspire cast, it would be a QWERTY keyboard and it would probably be faster. Since they're not allowed on the Texas assessment, we do not have those. Okay, there you go. There's decibel gain. That was easy. Now we are going to find the intensity of an earthquake. Really, I just crossed my eye. Don't cross your eye. Intensity of earthquake is measured by the Richter scale. Now, all of you that are in pre-cal right now, these words look familiar. Amplitude and period. Amplitude is how high and low a wave goes from the middle point, and period is how long each oscillation lasts. So,
And that's the Richter scale?
that is the Richter scale. Again, it's just plugging numbers into formulas. So you just take the numbers they gave you and plug them in. So you're figuring out how much this registers on the Richter scale. So that would be log. Again, it's common log, so you're going to have to put in a base 10. That would be your exact answer, but that doesn't help me much, because I don't know what that means. Plug it in your calculator. And I would guess if they're using Richter scale, they'll have you go 1 decimal place. I've never heard them on the news say anything more than one decimal place. So that would be 4.9 on the Richter scale.
It's kind of intense,
A little bit. Definitely more than anything we've felt around here. But, y'all felt one around here?
Don't they happen like every day, they're just like really?
Yeah, usually but every now and then, I can't remember since I've lived here if I've actually felt one here. But they're starting to happen more, and they're saying it's because the fracking, all the fracking that's happening around the state, that they're starting to happen more in places that aren't used to them. But if we were to feel one, it would be like a little less than that. It wouldn't be very much. But this one certainly wouldn't destroy the city. This isn't like that much, but.
What is a high number for that? Like,
Okay. Okay, now these are battery charging problems, like computer batteries and phone batteries. Okay, so this one has natural laws in it. Instead of common law this time. Okay,
natural log base of E.
yeah, that's log base E. Okay, so let me tell you what these letters mean, although you could probably figure it out, but K is a constant. So K is some sort of constant, and it's related to the battery and the charger. So every battery and every charger is going to cause a different K. M is a theoretical maximum charge. C is the charge level, like 70% or 60% or whatever.
And this says that it's given here a differential equation. That means that it is this.
Okay, so now I'm just plugging numbers into the formula again. So my K value they gave me is 0.025. My M value is my theoretical maximum charge. I don't really know that, but it's okay because you don't have to. I'll show you in just a minute. My charge level, they're saying to bring it to 90%. So I'm just going to plug numbers into the formula. T is what I'm looking for. I'm looking for how long it'll take. So I'm looking for T. So I got negative 1 over 0.025. Natural log 1 minus. Now, I want to go to 0.9%, 90% of whatever my maximum charge is. I don't know what that might be. But that's okay because I'm going to put it over maximum charge. Does that make sense? Like they didn't tell me how many volts was in my battery for a maximum charge. They just said they wanted me to bring it to 90%. So that's why I just put 90% of M. Does that make sense?
Oh, 'cause
Now,
those cancel.
they could potentially tell you what a maximum charge is. They could say, hey, a maximum charge is it's a 9-volt battery. So your maximum charge is 9, and if you wanted 90% of a 9-volt battery, it would be 8.7 or whatever. You would have to figure out what 90% of a 9-volt battery is. But they didn't tell me. But that's okay because my M's are going to cancel right here. And then I can just plug the rest of it in my calculator, probably just like that. It would be just fine, I'm sure. I got 90, approximately, because I rounded, 92.103 minutes. I'm sure they probably would ask you to round to the whole minute, I'm guessing. I don't know, but I bet. Just pay attention to what they ask for, so they don't count it wrong because you rounded wrong. Okay, now this is another population growth problem. We did one the other day on the exponential. We did Malthusian population. This is doubling population. There's the formula. So we are just plugging in. Don't forget to move your decimal place on your percentage. It's natural log of 2.02 because I have to move my decimal.
go to 4.6, like it said in the syllabus, or?
Yeah. So it's gonna go 4.4, we got 2 more. In his chapter.
Two more?
In his chapter.
Oh.
We have one in the chapter.
Okay.
Okay, last one in here. Okay. What is R? I'm getting there. Okay, R is a constant, and so on every problem that you, and it's like a legit constant. It's not a constant per, like that other one where the battery, every battery had a different constant that went with it. Now it was constant to that battery. Every time you use that battery, you're going to use that same K value. But get a new battery and it'll have a different constant. This is a legit constant. It's called the universal gas constant. I think it's the universal gas constant. I think that's what it's called. That is the number of joules or whatever that it takes for every gas has that same constant. So that's that. That R value is gonna be the same for every problem. I'm not sure why then they don't just plug it into the formula, but they don't. So there you go. So now let's do one and you'll see. Okay, so we're plugging numbers into the formula. I'm looking for E, because that's the amount of energy it takes. So I don't know E, that's what I'm looking for. R we know is 8.314. T is 300. And then my initial volume and my final volume, they didn't give me, but they did tell me that they wanted my final volume to be 3 times the initial volume. So
So 3 VI?
3 VI over VI. And that means your VIs would cancel. Oh, and I forgot my LN. It goes right here. I just didn't write it in. So you're plugging in your calculator 8.314 times 300 natural log of 3. And it's a lot. It's a lot of energy.
Joules.
Yes, joules. And that's it. Any other formulas that you might use in this section, they'll give to you in the